Chapter 4, Section 4.2, the unit circle. This is going to be part 2 of the video notes. We're going to start by defining even and odd trig functions. So cosine and secant are even trig functions, which means if I ever want to find cosine of a negative angle, like cosine of negative t, I know that it's just equal to cosine of the positive angle. Same thing with secant. For sine, cosecant, tangent, and cotangent, they are all odd. So if I want to find sine of negative t, I know that that's just equal to negative sine of t. In this first example, we're going to find the value of each of these functions using those rules that we just talked about with even and odd functions. So secant of negative pi over 4. We know that secant of a negative angle is equal to secant of that positive angle. So now all we need to do for secant is we are looking for 1 over x on our unit circle. So look at your unit circle. We're looking for 1 over x at pi over 4. My x value here is square root 2 over 2, so I'm going to write 1 over square root 2 over 2. I need to keep my first fraction, which is 1, flip the second one, change to multiply. And now I'm going to need to rationalize my denominator since there's a square root in the denominator. So I'm going to multiply the top and the bottom by square root of 2. And then I'll notice that my 2's cancel out, so I just get square root 2. To find sine of negative pi over 4, I know that sine is an odd function, so this is going to be equal to the negative sine of pi over 4. So again, look at your unit circle, look at where pi over 4 is, and sine is just going to be our y-coordinate, so we're going to get negative square root 2 over 2. Again, that negative comes because of the fact that I put it out front of the sign. Here are some fundamental identities, which we've kind of been using already in Chapter 4, since I expected you to remember that from geometry. So some reciprocal identities, sine is just equal to 1 divided by cosecant, cosine is 1 divided by secant, tangent's 1 over cotangent, and vice versa. We also have quotient identities, tangent of t is equal to sine of t divided by cosine of t, and the reciprocal for cotangent. Let's apply some of these quotient and reciprocal rules. So we're given that sine of t is equal to 2/3 and cosine of t is equal to square root 5 over 3. So for tangent, we know that that's just sine divided by cosine. So we're going to fill in what they're equal to. So 2/3 divided by square root 5 over 3. And then we need to keep flip change and rationalize here at the end. A lot of your calculators will do quite a bit of this division and rationalizing for you. Make sure you ask your teacher if you need help figuring out how to work them. For cotangent, we have cosine divided by sine. We've got the same thing going on here. Secant of t is just going to be equal to 1 divided by cosine. So after dividing and rationalizing, we get 3 square root 5 over 5. Cosecant of t is just going to be 1 divided by sine, which gives us 3/2. Now we're going to talk about Pythagorean identities. So we have 3 of them here. Sine squared of t plus cosine squared of t equals 1. 1 plus tangent squared of t equals secant squared of t. And 1 plus cotangent squared of t equals cosecant squared of t. We can use these identities and find information. So maybe I know what sine is. I could take that first equation there, I could plug my value for sine in, and I could solve for cosine. That's how we use identities. Here we're going to use Pythagorean identities to find cosine of t, given that sine of t equals 1/2. We're also going to restrict ourselves to the first quadrant. That's between 0 and pi over 2. I'll explain why at the end of the problem. Okay, so first of all, looking at our three identities, I know sine and I want to know cosine, so I'm going to use that first identity that we listed. Okay, so notice that we put the squared between the sine and the t. The reason why is it helps us know that that whole quantity is squared, so it's sine of t times sine of t. If you put the squared on the outside, it might look like it's saying sine of t squared. So that's why we put the squared right there. So we know that sine of t is equal to 1/2. So I'm going to replace sine squared of t with 1/2 squared. Okay, 1/2 squared, if I do that, 1/2 times 1/2, or 1 squared and 2 squared is 1/4. And then I can subtract over 1/4. All right, so now I have cosine squared of t equals 3/4. In order to get rid of my squared, which I want to do so I can find just cosine of t, I'm going to need to square root both sides. The square root of 3, we're just going to leave it as square root 3. And the denominator, square root of 4, becomes 2. That is going to be our final answer. Now, some of you may be thinking, but I thought anytime we put a square root into an equation, we needed to have a plus or minus. If you thought plus or minus on this, I want you to give yourself a pat on the back. The reason that we're only using the positive square root 3 over 2 is because we have restricted ourselves to the first quadrant. This is from 0 to pi over 2, and this is where x is positive. If we hadn't restricted ourselves to the first quadrant, we would have had to also consider the second quadrant, and that would have a negative value right here. So that's why we specified t from 0 to pi over 2.